engineering application will be asked in 5-mark questions. But you should not write the applications that you studied in medical should not be written in the field of scientific and engineering. The next topic is called holography. It's another important 3-mark questions. When you take a photograph of an image, the photograph of the height and the breadth is actually registered. It's called amplitude of an image is registered. So the registering the amplitude of an image will give you the two-dimensional idea of a two-dimensional structure of an image. But when you add the third dimension, sometimes we are saying the animation. No? What do you mean with animation? By recording an image along with the face. So recording an image with an amplitude and with the face will give you the animated feature to that image. That's called holography. So this is a simple technique that you can understand what is called holography. The next one is called a maser. So you know what is called a maser? Laser, you know that light amplification by stimulated emission of laser. What is called a maser? Maser, so the maser is exactly follows the similar principle of a laser. So when a light is amplified, we get the light in the case of laser, but in the case of light, we get a microwave, that becomes a maser. So maser uses the exact same principle of a laser. But what is the main purpose of the maser? Maser is used as the analyzed what is called the molecule structure of the molecules in the field of molecular spectroscopy. And what are the substances which can be used as the maser material? Or ammonium can be used as the maser material, and then gadolinium, and which is doped by ionic crystals, can also be used as a maser materials. Even paramagnetic substances can also be used as a magnetic material, or it's called maser material. But in general, a maser, which is used as a diagnostic tool for accelerating, for studying the molecular structure of the molecules. So next we will see a few problems in this chapter. So first one is called the first exercise problem. An electron beam passes through a transverse magnetic field 2 into 10 to the power minus 3 Tesla and an electric field of 3.4 into 10 to the power 4 volt per meter acting simultaneously. If the path of the electrons remain undeviated, calculate the speed of electron. First of all, you have to calculate the speed of an electron. If the electric field is removed, what will be the radius of the electron? What will be the radius of the electron path? So the magnetic field strength is given as 2 into 10 to the power minus 3 Tesla. The electric field strength is given as 3.4 into 10 to the power 4 volt per meter. First of all, you have to calculate what is the velocity with which the electron moves. V is equal to E by B. Okay, 3.4 into 10 to the power 4 volt per meter and 2 into 10 to the power minus 3 will give you the answer 1.7 into 10 to the power 7 meter per second. And they are asking what is the radius of the circular path if the magnetic field is removed, the electric field is removed. So R is equal to mb by bq that you have studied in the cyclotron as well as the charge, most of the charge particle in the presence of magnetic field. So 9.11 into 10 to the power minus 11. And velocity is 1.7 into 10 to the power 7. And magnetic field is 2 into 10 to the power minus 3. And Q is 1.6 into 10 to the power minus 19 coulomb. So we are talking about only the mass of the electron and the charge of an electron. We will give you that 4.834 into 10 to the power minus 2 meter. So this is the radius value, this is the speed of an electron. The next problem is calculate the distance of the closest approach of alpha particle of a copper nucleus when alpha particle of 5 MeV are scattered back by a thin sheet of copper provided the atomic number of copper is 29. So what is the formula which we can apply for finding the closest distance approach? So R naught is equal to 1 by 4 pi epsilon naught. I can say that 2 ZE square by, so 4 ZE square by 4 pi epsilon naught into mv square. Here they have got a copper nucleus and alpha particle in energy is given. So I can say 2 ZE square by half mv square. So this is nothing but EK, kinetic energy of an electron. So R naught is equal to 2 ZE square 4 pi epsilon naught into an EK. This EK is given as 5 million electron volt. So this is equal to 5 into 10 to the power 6 into 1.6 into 10 to the power minus 19 will give you 1.6 into 5 will give you 8 into 10 to the power minus 13 joule. So R naught is equal to 2 into, what is the atomic number is given in the atomic number of a copper is given in the problem, 29. 2 into 29, 1.6 into 10 to the power minus 19 the whole square. Then 1 by 4 pi epsilon naught will give you 9 into 10 to the power 9. You can straight away substitute. Then EK is kinetic energy is 8 into 10 to the power minus 13. When you substitute, you will get R naught is equal to 1.67 into 10 to the power 1.67 into 10 to the power minus 14 meter. So this is a way in which you can find the answer for this. The next one, so how much should be the voltage of an X-ray tube so that electrons emitted from the cathode ray given an X-ray of wavelength 1 angstrom after striking a target? So we have to calculate what must be the potential difference applied for producing the 1 angstrom of an X-ray. So lambda minimum is equal to 12,400 angstrom by V. Then we have to calculate what's the V. So this is given as 1 angstrom in the problem. So V is equal to 12,400 into 10 to the power minus 10 by lambda 1 angstrom. So 1 into 10 to the power minus 10. So this thing can be cancelled. So V is equal to 12,400 voltage, which is nothing but 12.4, so kilovolt. So this is the answer. The last one, find the minimum wavelength of an X-ray produced by an X-ray tube at 1000 kilovolt. So this is the last problem in an exercise. Find the minimum wavelength. So same formula can be applied. So this voltage is equal to 1000 kV, is equal to 1000 into 1000 volt is equal to 10 to the power 6 volt. So lambda minimum 12,400 into 10 to the power minus 10 by 10 to the power 6. So when you cancel this, you will get the lambda minimum is equal to 0.0124 angstrom. So with that, we come to the end of this topic.